Are you looking for a career that's fast-growing, high-paying, and always in demand? Welcome to the world of DevOps. With companies worldwide moving toward cloud adoption and automation, the demand for DevOps professionals has skyrocketed. Businesses need experts who can streamline software development, speed up delivery, and ensure systems are secure and scalable. And that's exactly where DevOps comes in. So in this course, we'll start from the basics, making it perfect for beginners. You'll explore DevOps fundamentals and then dive into powerful tools and concepts that are shaping the industry. Here's what we'll cover in the video. First, we'll go through a DevOps tutorial for beginners, a solid foundation, and understand how DevOps bridges the gap between development and operations. We'll have a look at Kubernetes architecture, learn how container orchestration works at a scale. We'll also compare between Kubernetes and Docker. You'll discover the key differences and when to use each. Jenkins, where you can automate your CI/CD pipelines like a pro. And at last, we'll see top 10 DevOps projects you work on hands-on project to build real-world skills. Plus, we'll also prepare you with the most asked questions to boost your confidence for job roles. And by the end of this course, you won't just know DevOps, you'll be ready to apply it, crack interviews, and take on exciting roles in tech companies worldwide. Now, before we move on, here's a quick information. If you are looking to future-proof your tech career, this professional certificate program in cloud computing and DevOps by ENICT Academy, IT Guwahati is the perfect choice for you. In just 8 months, you get hands-on expertise across AWS, Azure, Google Cloud, master DevOps tools like Jenkins, Docker, Kubernetes, and work on 30+ real-world projects. And what makes this program stand out? Well, you'll get official Azure certification, IIT Guwahati issued credentials, access to live masterclasses, and even a campus immersion opportunity. So whether you're upskilling or making a career switch, this program offers everything you need to know to thrive in the world of DevOps and cloud with IIT-backed credibility and practical learning that actually sticks. So what are you waiting for? Hurry up and enroll now and you can find the course link below.
Today we're going to go through a complete end-to-end journey on what it takes to set up a DevOps team. We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps. And then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called waterfall, and waterfall was a very traditional approach to actually building out solutions. And the reason why it's called waterfall is that you break out all the individual requirements and individual sections of a project and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing. This is all based on the software development lifecycle model, or SDLC, and it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints. sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into, though, with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system, and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment. And you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different, or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with Waterfall and Agile, where developers and operations teams aren't working in the same environment, is being removed, and you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is, when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions, and DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen, what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other so that you're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working and, more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now. So let's dig into Git. So let's look at the challenge that Git is able to address. So before Git, and if you had a team of developers that were working on different pieces of code, one of the key problems you have is that there was no collaboration between the team. And the challenge you have is that with version control, it was difficult and often required having to check into large environments, or you had very quasi version control environments. It was time consuming. Often there were problems that what would happen if the version control server would crash and there wasn't a backup, then you'd have to kind of essentially go back to square zero to see whether or not you actually had to do the work again. So let's look at what Git does to actually solve this. So first of all, one of the things that Git does is it makes team collaboration much easier. The software itself is more effectively documented and more effectively maintained. The actual code that actually gets worked on by each developer in a Git environment is the complete code. So it makes it much easier for backups and for sharing content amongst each developer. So the way in which Git is able to accomplish this is that it is essentially a distributed version control solution. And what that means is that when you have multiple developers, yes, you do have a Git remote hub that you connect and are able to upload and download different branches of the code that you're working on. But essentially, as a developer, when you actually have the code, you actually have all of the code, and you're able to manage it directly from your local PC or your local development machine without having to worry too much about the network or the server actually going down. So some of the key things in which Git is really good at, it is a software management tool. It's designed from the ground up to manage code development. It does track the changes on that code easily and effectively. It makes it easy for you as a developer to track your code. The ability for multiple developers to work together is much easier in comparison to other solutions. And this is really the key success point with Git, is that it allows for non-linear code development. So you can actually have people working on different areas of the code that may be released at different times because of what they're working on. So if we actually break down the architecture of Git, it really falls into 4 key areas of a working directory, a local staging area, a local repository, and a remote repository. So the process you would go through is you would add files to the staging area from your working directory, and this would be usually the git add command. And then from your staging area, when you're ready to actually then commit those files to a local repository, you would use the git commit command. And then from there, you would actually then push your local repository out to the remote repository for a final commit to the remote repository. And this allows then the rest of the team to pull down your latest final changes. So you can be working on your code locally, and you can be using your local staging area, local repository, and when you're ready to commit your work, you can commit it. And then as soon as it's committed, the rest of the team can then pull down the latest changes that you have worked on. And this allows for a complete and holistic checkout and check-in process. And then sometimes you want to be able to go through and then take the checked out code that you're pulling out and merge it with your local code. And the merge process always ensures that you are working on the latest and best version of the code, and everybody on the team is being consistent with the communication of the actual code that's being delivered. Okay, so what we're going to do is we're going to validate that we have Git running on our computer. We're going to then create a directory, add a file to that directory, make some changes to that file, and then use the commit commands to be able to check in the files and validate changes that have been made. So first thing we do is we're going to see if we have Git installed, and to do that you just use the command git version and git -- version, and they'll actually then give you the version number. And now we're going to create a new folder, so mkdir green, and that'll create a new folder, and we'll move our cursor into the green folder by changing the directory. And And we can go back into Windows and we can validate that that directory is actually there. So here we go. Let's have a look. We should see it. There's the green folder. If I double click into that, you'll see there's nothing in the folder right now. So what we have to do is we actually have to add the folder as part of a Git project. And so we're going to use our Git initiate init, and they'll actually initialize the folder and make it a Git repository. And so let's go ahead and create a file that'll actually go inside of that new initialized folder. And you'll see that there's a .git folder that's been added. So the new text file we're going to create is going to be called class, and it'll actually be class.txt. The extension is hidden by default. In the text file, we're just going to type in the text, welcome to Simplilearn, and save that. Now let's go ahead and check the status of that file in Git. So let's do git status, and you'll see that it says yes, there's a file there, but it hasn't been committed to the repository. That's why it's in red. So what we have to do now is commit the file to the repository, and it won't be able to track any changes that we do to that file. So let's go ahead and commit the file. So we do commit add class.txt, and they'll add that to the repository, and there we are, it's added. And the final step is we want to do is commit it, and let's do git. So let's do git commit -m, put in, this will be our first commit, and this is the description, and so it actually shows us committing the file. It's the only item in the folder. So now we can go over to the file that we just created, and we can make some changes to it. So let's open up the file. So it says welcome to Simplilearn. Let's put in some text afterwards that says this is my demo, and we'll save that, close that. And now if we go back to Git, we can do a compare and contrast between the original file that we committed and the new updates that we've just done. And we can check the difference by using git diff, and what you'll see is the red text was the original text, and the green text is now the new text that's been added. And so that shows you how you can actually go and create a new Git repository, go through adding files, committing the files into the repository, and being able to see the different version controls. Let's move on to Maven. So why use Maven? So why use Maven? Well, let's look at some of the things that you would have done in the past if you actually building out the tasks. So let's break down what you would have done before using Maven if you were to create a game of football using Java. You would actually have to go out, and for your actual game, you'd have to collect all of the different components needed within the Java environment to make sure that everything would work correctly. And if you made the slightest mistake, you wouldn't get the right output that you needed. The actual process of building and deploying a project really would take quite a lot of time. After Maven allows you to be able to take templates that are stored locally and be able to use those to be able to improve the efficiency of being able to build out your environment by removing dependencies within the application. It makes it a lot easier for you to be able to focus on just writing the code for your game or your solution rather than having to manage the environment within which that solution would be deployed. Now, the focus within Maven is that it is an automation tool, and it's used for projects that have a short period of time. So as you're starting on your environment for building out solutions, Maven is great to get started with. And then if you need to have longer term projects, then you can look at other alternative tools on the market. So 4 key areas that you want to focus on and why Maven can help you is that it does allow for efficient parallel builds to be run concurrently. It's really easy to use. You can get up and started with Maven very quickly. You do have fast access to new features and new configurations quickly within your environment, and the build process that will allow you to be able to visualize your code happens very quickly. The actual architecture of Maven is that the execution and commands are managed through what's known as a POM file. The POM file itself is a project object model, and it's an XML file that actually has the details for the project and the configuration for the build environment. POM file itself will then fetch dependencies from the local repository and will apply any plugins that you may have also included within your Maven environment. The goal is that your software is built in a much more controlled manner. So what we're going to do now is we're going to show you how to go through and run your very first project using Maven. The first steps you're going to have to do is make sure that you have the latest JDK installed on your computer. So we're going to go ahead and open up our web browser and get this installed on your computer. So we're going to type in JDK download into our Chrome web browser and go to the Oracle website, which allows us to download the JDK. And because we're running this on Windows, we're going to download the Windows version of the JDK. And once you have that installed, so the next step is to actually then go ahead and download the Maven files. So it's going to take us to the mavenapache.org website, where you can actually go ahead and download the version of Maven that you need for your operating system. We're going to go ahead and download the zip file instead of just an executable file. Now this will give you more control over how you install it onto your Windows PC. After the file has been downloaded, we want to go ahead and extract the entire file, so you have the unzipped folder running on your computer. So one of the things that we're going to have to do is go through and set a number of system variables for the JDK and for the path to your Maven files. And to do that, you want to go into your control panel and select the system security and then system settings, and then go into advanced system settings. This will give you access to the edit system variables setting that you're looking for. So we're going to go down to the path variable, and you'll see already that we have pasted in the link to the JDK right there underneath the variable value. If you've installed the JDK, it's likely that it's already installed this path for you correctly. The good news is it's actually fairly easy to install the path to Maven and to the JDK, because all you have to do is copy the path for where the folder is located on your system and just paste it into a variable value under the edit systems variable file system. And that should now get us all of the files, and we can see that we have our extracted folder already on our desktop there. And the system path is now set to where the Maven folder is located. So we also have to go into system protection and set the system path to your Maven folder. Now we have to go ahead and do a user variable that also links to the path of the Maven files. So what we're doing right now is we're just validating that all the files have been extracted correctly. They have, which is good. We can now go ahead and link to this Maven folder. All right, so now what we're going to do is we're going to move over to command prompt. And this is where we're going to do most of our work from here on out. First command we're going to do is mv. So we're going to go ahead and create a new user variable, and we're going to type in, we're going to call this one m2 dash, and then we'll put in the path to the Apache Maven folder. You should be able to use m2 dash home for your project, but if it's not, you can always use the variable name Maven dash home, and that will do exactly the same as m2. We're going to do both here just so we have a backup. So we're going to open up command prompt and we're going to see if Maven is installed. We do that by writing mvn --version. And here we are, yes. So now we're going to go ahead and create our first Maven project. And the first part of creating the Maven project is actually the directory in which we will store the files that will be used to create for our project. So we're just going to go ahead into the folder and we're going to create a new directory, and we're going to call this one, and we're going to call it Simplilearn. And we can just copy the path for that. So I'm going to write the correct path for us. So we're going to change directory, cd, and copy the file location over. All right, we are now moved ourselves over to the Simplilearn folder, and we'll be able to install the POM file, which is what all the instructions from Maven are stored in, into this area. So to do that, we're actually going to use a template that's already been created by Maven, and this is going to be the mvn archetype template. And so you just do mvn archetype :generate, and this will go ahead and create all the files for us. So there can be quite a few files, and they're all being downloaded from the Maven website. So it can take some time, but as you see, we've gone ahead and all the files have downloaded, and we have everything up and running correctly inside of our environment on command line and command prompt. So we'll have some values that we do have to set. The first one is group ID, and we're going to call this one com.mav. And then the next one is going to be artifact ID, and this is going to be mav project. Hit return, and then version is going to be 1.0-snapshot. We'll just put in the same value for this version, which will be 1.0-snapshot. And the package, we're going to call this one com.mav.demo. And then we'll select yes or Y to create the environment, and it will build the environment for us. And what we have now is we have this screen which shows everything is up and running for us. And we have a successful build. So let's go into the Maven folder and just see. There we have our Simplilearn folder. Let's open it up and see what's in there. So we double click into that directory. Yep, and there we are, starting to see some of our files. So it's the same project names there as mav-project. And then we have our POM file that's in there, which is fantastic. Under the source folder, we'll actually see the demo, and we have our app under the demo app. We have our test file as well. So in the main folder, we have a file that's called the POM file, and that really is the most important file that you need for your project. You'll now go in, you'll be able to set all your settings inside of that POM file. But that's it. That's what we have done here. Is we've gone through all the setup that allows you to make sure you have the right files running on your computer, the right files to download from the Maven website, how to install all of the files, the settings you need to make on your Windows computer, and then all the settings that need to be done in the command line to be able to run the application. And then from here, you can actually start running Maven. Now let's look at Selenium as we start looking at testing. So before Selenium, if you wanted to run testing, and particularly if you wanted to do sequential testing, it would take up a lot of time. You'd have to run one test, then a second test, and then all of the other tests, and the actual time elapsed would be quite significant. With Selenium, you're actually able to do parallel testing. So instead of looking at the amount of time it would take to actually run a test and run the test sequentially, the length of time to actually run your test is based on the length of the longest running test, of which in this example, the longest running test is 2 minutes. Now, one of the things that you'll notice with Selenium is that its focus is on web applications, and it is an open source tool, and it's really good at regression and functional testing of web applications. If you're doing a mobile application or if you're doing an IoT application, there are other tools you can use on the market as well. But if you are new to DevOps and you're setting up your first DevOps environment, Selenium is a great place to start, and web applications are mature and allow you to be able to test out and validate the concept of continuous testing in your environment. So 4 key takeaways for Selenium. It really is fast. Fast execution, it's highly accurate, so you can always validate that what you're doing will work correctly, and feedback can be sent straight back to the developer if their code doesn't pass the test. It allows you to script in multiple languages. Again, this is a great way for you to test. The focus is on web applications, but you can test in multiple languages used for web applications, and most importantly, allows for parallel test execution, which speeds up the whole test process significantly. We're actually to break down the architecture of Selenium. What you'll find is the actual libraries that you can use for Selenium run in C#, Java, Python, JavaScript, PHP. These are the common languages used to build out web applications. The actual web driver itself is an API driver, which is fantastic because it makes it easier for you to integrate Selenium with applications through API. And you can run the solution through different web browsers, the most popular being Firefox, Chrome, and Edge. So to focus, the Selenium WebDriver codes are being used to build out the client libraries that make it to allow you to be able to build solutions across multiple web application environments. The WebDriver application interface is used to integrate with the application to make it easy for testing. The WebDriver service provides an immutable stateless environment that makes it very easy for you to be able to use protocols such as JSON to wire up your test environment. The driver manages the communication between the browsers and the wire protocol that's used for JSON within the web browser itself, and then the actual commands are then run through the web browser for you to be able to get your results. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download, and here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already, so we have everything running. And now the next step is for us to install all of this great content. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download. And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version. And we've gone ahead and done that already, so we have everything running. And now the next step is for us to install all of this great content. So we're just going to go ahead and open up the Eclipse environment, and it always takes a moment to launch Eclipse. And we're going to go ahead and create a new project, and we're going to call our project XYZ. I think that should be fine, and this is just a test after all. And we're going to go ahead and create a new class file by right-clicking and select New Class. And we're going to go in here and we're going to give the class file a name of Simplilearn. And I don't see the Finish button being selected, so maybe we need to select some other options here. Oh, you know, I think it could be the package name. Yeah, let me go ahead and change the package name, and I'm going to change that to QWE. Yep, and the Finish button has now been highlighted. I can select that. I can go select that and select Finish. And we now have a test page that's up and running, but what we have to do is to validate that Selenium is actually part of the project. So to do that, we're going to go to the source, to the actual source XYZ file, and right-click on it. And we want to validate that all the files are there correctly. And so we're going to see that we have the libraries are there. Yep, there's Selenium. If it's not there, you can select Add External Files and find the Selenium jar file, select Open, and that would load that in there. And then you hit Apply and Close, and that would then apply it to your project. And now we can actually start writing the code part. So we're going to put this code in the public static void section. And the first command is going to be a system.setProperty, and we want to make sure that we're configuring the WebDriver for Chromium correctly. So we're going to do WebDriver .chrome driver, and then the argument is actually going to be the full network path to the Chromium driver that you have on your PC. So let's see, we have Chromium here. We want to copy that path. And so paste that in. And then after we've pasted in the path, we have to make sure that we also put a link to the actual file that we want to execute, which in this case is chromedriver.exe. And then we want to make sure that the WebDriver is pointing to the new Chrome driver. And you'll notice that there's a couple of red colors on here, which means that we don't have all of the public classes imported correctly. So you can right click on that and select import the WebDriver and just select that real quick, and that adds the import correctly at the top of the page. And the same for Chrome driver. And that's just a very quick way when you're working in Eclipse to import additional files. So before we actually start our test, we want to make sure that we've actually cleared out any potential browser cookies that would be within the Chromium driver. So for that, we're actually going to go ahead and we're going to write a script that allows us to remove the cookies. So we want to do driver.manage and then delete all cookies. And the next line we're going to do is to actually have the web page that we're going to connect to open up in full screen mode. And for that to happen, we're going to go and actually use the window property, which is what I was writing before by mistake. And so this will allow us to go full screen. And now we need to pull in a web page. So we're going to get the get command. And what we're going to do is we're actually just going to pull in a web page from Amazon, which I just happen to have here. So I'm just going to go to the Amazon web page, and so I'm just going to copy the URL. Just need to copy HTTPS www.amazon.in or .com, wherever you're located. And so you can see that I've pulled in the Amazon web page, and then line 18 actually allows me to go and connect. So here we are, we have the Amazon web page that I'm pulling in. And then what I also want to do is I want to look for a specific ID in one of the elements. And so I have the driver, which is called find an element. And that allows me to look for any element that would be on the actual page. So here we have the HTML in the console screen, and I can actually then paste out an ID from the element that I want to use. So the find element is just the ID for each element, and most of them have them because they need it for JavaScript and CSS. So let's see, there's quite a few IDs, and we can select any of those. So what we have here is we have two-tab search text box, and then what that actually does is that finds the ID for the text box used for searching. And then we're going to use the send key command, which allows us to actually pre-fill in the search box. And we're going to use the test of Puma shoes. This is a fixed string, but you could actually put a variable in here if you want to pull strings from a database or an XML file. And then the next line on line 19 shows how long we're actually going to run the actual script for the search, which is only 10 seconds. And then once the 10 seconds has elapsed, we'll actually quit the script, which actually closes the web browser and takes us back into our screen here. And let's test that, make sure it's working. And everything's looking good. The web browser opens, which is what we expect. It goes to Amazon, fantastic. It now actually goes to the search screen and should fill in the Puma shoes. There we go, Puma shoes. And waits 10 seconds and it closes. And that's exactly what we were expecting. Now you can actually change the unit of time that you would have for the actual test. So if you wanted to see what was happening, so longer than 10 seconds, you can actually change the actual time or the actual metric. So in this instance, we got it as seconds and it's a unit of time, but you could do minutes or hours or microseconds. And you can change the keyword as well. So it could be jigsaws or anything that you wanted to check. But if you're actually building your own application, you want to be able to test your own data against your own application, that's where you put in that specific data. So let's look at the center, the heart of your DevOps environment, and that center is with Jenkins. So before Jenkins, developers would work on their code, and the code would then be checked into a source repository. You would then check for any issues, and then you would then send that code over to the operations team, and there would be a delay for actually delivering software. So the actual challenges developers had is that if they wanted to run any tests, they had to wait until their software was built, and there was a lot of problems in providing feedback, particularly if you had large teams working on software who actually had the error. The actual delivery of software was often delayed because of these key problems. So after Jenkins, what we actually have is the ability to be able to streamline this whole process. The build, test, and deploy happens continuously and are able to then notify developers and the actual specific developer of any errors that are detected, being able to speed up the delivery process much more efficiently. The focus of Jenkins is that it automates a continuous development, testing, and deployment environment. And it's open source. Jenkins is easy to install and configure. It's been around for many years now, and it is very mature. There are many plugins that you can use within Jenkins to be able to have the Jenkins product work with your environment. If there isn't a plugin, you can actually you can actually write your own plugins if a plugin doesn't exist. So you can actually continue and extend and invest in the Jenkins ecosystem, and it can be easily distributed across multiple machines. So let's break out the architecture of Jenkins. So Jenkins starts as a remote source code repository, and it then pulls out the code every time there is a commit from into the server master. The server master will then have a slave that will run on either Windows, Linux, or Mac OS to be able to distribute its load across those environments. And after it's actually gone through and run its test, it'll then send out a report. The goal of the report is to communicate back to the team what has passed and what has failed, the actual check-in process. Okay, so we're going to go ahead and show you how to install Jenkins on your local PC. So the first thing you want to do is check that you have Java installed. So we're just going to go into our system and see whether or not we have the Java JDK installed. You can do that by going into System Properties, Setting Advanced, and then Environment Settings. And there we are. We have Java JDK installed. And you want to just double check on the system variables to make sure that you have the Java_home installed correctly as well. And we have that installed. And under path, also make sure you have a link to the Java JDK as well. So we have everything installed. And what we're going to do is we're going to open up a command window and just do a double check right there. So open up command window, and we're just going to check that we have Java installed. So we do Java-version, and we have a version number that comes back. If we didn't have Java installed, we wouldn't get a Java version number come back. We'd actually have an error. So everything looks good. So the next thing we want to do is to go to the Jenkins website and download the files. So we're going to go to jenkins.io, and that's the official Jenkins website. And if you want to download, you just go to jenkins.io/download, or you can just type into your search bar download Jenkins, and that will give you a link straight to the download page. And one of the things that you'll see is that there's lots of different versions for Jenkins, because Jenkins runs on pretty much most operating systems, including Windows, Linux, and Mac OS. But we want to select the Windows version. So we've already gone ahead and downloaded a zip file which contains all of the files that we need for Jenkins. And so that's the zip file, and we've expanded it. And what we want to do now is double click the installer file, and we'll go ahead and install that. So we've already installed this. So one of the things that we'll get is a message asking if we want to repair. You would actually get a install message because it'd be a fresh install for you. But once you've done that, it has all the files and all the settings correctly installed onto your Windows computer. And we do all of our commands for Jenkins through a web page that's run locally on your PC. And so you're going to type in localhost:8080. And when you do that, that'll actually take you to Jenkins running locally on your PC. And here we have our Jenkins dashboard. And we've already gone in and created some sample jobs, and you can see those listed on the on the right-hand side of the screen. So let's go through some of the things you would want to set up here. So first of all, let's go into the Manage Jenkins screen, and that will actually, so we'll go to the Manage Jenkins tab on the left-hand side to do some standard configuration settings. So we'll go into the configuration systems, and if you want to, if you're like remotely connecting to a remote Jenkins environment, you can actually install a JDK remotely on that machine if you want to. We already have the JDK environment already set up, so yeah, that's good here, so we don't need to do that. But you'll also see as you go through the list of applications that you have: Gradle, Ant, Maven, Docker, Git, and other tools that you would use in a DevOps environment. There are many other tools you can install through plugins as well. Let's have a look at one more setting here with the security. The default security is Jenkins' own user database. That probably is not allowed within your company due to security restrictions. So you can choose LDAP, which allows you to connect with your Active Directory configuration. Again, because there are so many plugins for Jenkins, there are plugins for SAML authentication as well as OAuth. So let's go ahead and start a new build job. And so we'll select a new item, and we're going to select demo 1 from that to create a new item. And we're going to use just a freestyle project because I just want to demo how you can actually create a build. Select OK. Description, gosh, what can we write here? We can put in Snippy demo. And we're not going to use source code for this one. We're going to do that in the next demo. But what we want to go down to is the job type. And we're going to, build, we can just do add for execute Windows batch command. And so let's just put in a very simple command. And so we're going to type in echo, open quotes, hello world. And then we'll put in the timestamp. So we'll put in date first and then time as part of our output. Close quotes. And we're going to save that. Also hit save. And that's our simple project. So what we want to do now is we want to actually go and select the build now command to actually run this project. Hit build now, and it'll take a couple of minutes for it to run. And here we are. This is our project, and we can actually now see the different builds that have happened. And if you look on the build history, you'll see the latest history shows when the build was executed. And if you click on that, you can actually start getting information such as the console output will actually provide information that we were asking for. So for instance, we have, first of all, we can see that the build was successful, and we see the output includes the hello all and date and time. So we're going to go ahead and create one more project where we can actually connect to a GitHub and use the Git command tool to be able to build a real project. So we're going to go ahead and create a new item, and we're going to call this one Jenkins. It's a freestyle project, and our description is demo using Git. So we're actually going to connect to GitHub. So to do that, we're going to go into Source Code Management tab, and we're going to select Git. And so we select that, we can actually now connect to GitHub. So to do that, you go to your GitHub account, and you want to go in and select the clone or download, and you get the URL link from there. So copy that, go back to Jenkins and add that in the repository URL. So you paste that in. And then for credentials, we want to add in our Jenkins credentials. And so just make sure you have those selected correctly. And we've select add, and then we just pull those from the drop down. And let's not change any of the other settings. And then for the build, we're actually going to be building a Java application. So it's a slightly different set of build commands. So we want to type in javac for compile, and then space, and the file name is simply.java. And then you want to put Java and space simply on a new line. Save that. Again, this is a really simple application, but it gives you the understanding of what you need to do here. And so we saved it, and let's now go ahead and see if everything's working. We'll do the build now and see what happens. And here is our first build. We select that. We can go to the console console output for details, and what we can actually see if we scroll down is that the finished output at the very end says success, which means everything was built correctly. And so that's how you're able to connect Jenkins with a Git repository. And the thing that's great with working with Jenkins is that it connects to so many different systems and really does become the central point of your DevOps toolset. So let's start looking at the operations side of the DevOps environment, and let's focus in on Docker. So before Docker, the problem you had as a developer, if you were working on a virtual machine, the actual virtual machine was your VM, was a very complex piece of software. So first of all, VMs have not been around for very long, and we're talking about less than 10 years. And the typical way of having a VM is that it's very heavy on usage on your computer. You essentially are running everything of the VM plus the tools to run the VM on your computer. With Docker, what you're able to control is the actual development environment you're working in. You don't have to be encumbered by all of the additional extraneous processing that a VM environment has. You're really stripped down to just the bare minimum that you need to have to run the environment using a containerized solution known as Docker. So Docker is essentially an OS level virtualization software. It is a maturity of the solutions that were started with virtual environments, and there are other solutions out there. Docker has become the de facto container solution that you can use for building out and guaranteeing that what the developer is building is going to be the same as what the operations team will use. So Docker itself is highly scalable and efficient. You can have many Docker environments running on a single piece of hardware. The boot up time is incredibly short. You can reuse the data volumes very, very easily. It's not complicated. And the actual applications are completely isolated. This is like a perfect sandbox environment. So let's dig through the architecture of Docker. So there are really two parts to Docker. There's the Docker engine and there's the Docker client. The Docker engine is comprised of the Docker CLI, which connects with the server daemon. The Docker client will then issue the commands to the Docker daemon. And then the Docker daemon will then interact with your system to be able to provide the tasks and tools needed for you to be able to build out your solution. The actual images that Docker uses are instructions for creating Docker containers. And the actual Docker container itself is a lightweight package that contains all the dependencies needed to run an application. Now, once you have created a container that is of value to your team, you want to be able to store that container so that other team members can use it. And this is where you would use a Docker registry to be able to host and distribute multiple Docker images. So in this video, we're going to go ahead and see how we can get Docker installed and running. So we're going to go ahead and open up our terminal window, and we want to validate whether or not Docker is installed. If you haven't installed Docker, you can actually go ahead and use the following command, and that is to enter in sudo apt install Docker, and that will go ahead and run the command to install Docker. I already have Docker installed on my system, so I'm not going to do that right now, so I'm just going to delete that out. But what I am going to do is check to see what Docker images I have installed on my system. And to do that, I'm going to type in sudo docker images. And when I run this will actually show how many images I have. And right now I don't have any images at all. So why don't we go ahead and install an image. There are two ways you can create an image for your Docker environment. One is to get one from Docker Hub, and the other is to create your own image. Let's go ahead and get one from Docker Hub. And so the command line that we'd want to write is sudo docker pull redis colon, and after the colon, we're going to actually write the name of the actual file that we're going to be connecting to from Docker. So I'm going to go ahead and go to Docker Hub, and I've already logged in with my user ID and account. So I'm going to go to Docker Hub, and it's hub.docker.com is the website address, and I'm already logged in with my Simplilearn account. And what you can actually see is different repositories that I have already created below. But I'm going to click the Explore button, and I can see the Redis image. And these are all the different commands that I can actually use, all the different variations that I can create. So I can do 5.0, I can do a 32-bit version, I can do a 4.0 version or a 3.8 version. Or if I select latest, that will allow me to just pull the latest version, even if it's updated. So I'm going to go back to my command line and do latest. And what's going to happen now is that we're actually going to pull the files live over the internet and create the Docker image. So this is going to take just a few minutes. Of course, if your internet speed is faster, then this will happen a lot faster. And here we are. We have everything downloaded, which is great. And so let's just go and check and see if the image has been added to Docker. So we do sudo docker images, and now you can actually see that we have the latest Redis image, and it's given the default image ID, and there's the size of the Docker image. And the tag is latest, so it's the latest version of Redis. And I'm just checking to see if there's any other images running, and no, there isn't. So let's go ahead and now create a container. And so the command for that is sudo docker run -d -p 0.0.0. I think it's .80:80 space Redis latest. And let's run that. Got an error message. Okay, now you know that it's a real demo. This is really live. So I'm just going to clear the screen and let's write that in again. So sudo docker run -d -p, and it's 0.0.0.0:8080 Redis.latest, and there we are. Everything's up and running. Awesome. So let's just go ahead and check that we actually have the image running in Docker. So sudo docker ps, and there you can see that we actually have the latest Redis version, and it was created 16 seconds ago. We have a new container ID for it, and there's our port that we've created. And let's see if we can view all the running containers. And sudo docker ps-a, and there we are. And we created that container 42 seconds ago. But one of the things you'll notice is the name for the Docker is created automatically by Docker. And here we have Stupefied Engelbarts is the name. Let's change that name to something that's more meaningful for the work that we're doing. So that's actually fairly easy to do, and it's going to be our final task here. So we're going to type sudo docker, and the command is rename, and we want to copy over the old name, and then we put in the old name, and then you do a space, and then you put in what you want the new name to be, in which case we're going to make it Simplilearn. We run that command. That's good. Now let's validate that everything has been changed. So we're going to do sudo docker ps-a, just ps. And there we are. Everything has been renamed. And that gets you started working with Docker. Now let's move on to Ansible. So before Ansible, the ability to be able to deploy software across a network was pretty hard. You couldn't guarantee that your web servers were all consistent and that the database environments were consistent. This was okay if you had a small environment, but once you actually start getting into more complex environments, it became very difficult to manage. Ansible is code that allows you to be able to consistently and reliably create and stand up the environments that you need to be able to store your code for production. So whether or not you require one server environment or you need 1,000 server environments, using tools like Ansible will allow you to be able to consistently deploy out environments that all look the same. So essentially, Ansible is a configuration management tool, and it allows you to be able to deploy automatically to a large variety of environments. The actual tool itself is a push-based configuration tool. It is an agentless tool, so there is no communication coming back about the health of the environment. We actually have tools that we'll cover later on in the video that cover that. Ansible does have a consistency of its product performance, so you know that if you're using Ansible that it's going to work. It's just a very consistent product, and it uses SSH for very secure connections. So it doesn't matter whether or not you have 1 or 1,000 pieces of hardware you're looking to configure, you can actually be rest assured that there will be no security infringement because of the use of SSH. And we look into the architecture of Ansible. It's a very simple architecture. There is the Ansible management node that has playbooks which contain the instructions that you would have for your environment, and that playbook is then pushed out to all the different nodes that contain the hardware that you wish to configure. The actual module collection is the configuration code itself. The playbooks are the instructions of that configuration. And then the inventory is the document of the different groups and the hardware within those groups that you would be pushing out to. So we're going to go ahead and install Ansible onto the system here. And we're actually running our environment in a Linux environment right now. So we have a master environment and a standard node. But we're actually going to go into our terminal window and we're going to do everything on the master node. So the first steps we want to do is actually go ahead and install Ansible. And we're going to do that by installing sudo yum install ansible-y. And this goes ahead and downloads all the files that we need and starts to run the installation. And let's go ahead and see if it's installed correctly. So we're going to type in vi-etc/ansible/hosts. And there we see we actually have a default Ansible hosts already up and running, which is fantastic. And we want to grab this IP address, which is Ansible servers, and then the IP address with the password and root access. And the IP will be specific to your local client. So this is my client system. So if I type in my config, I'll actually see that the IP address matches up. And then you want to make sure that the IP address is correct for your environment. And so this is essentially a node in the Ansible environment, and this is the IP address and the password for that node so we can access correctly. So we're going to hit colon at the bottom of the screen and take ourselves actually into Ansible. And what we're going to do now is create a playbook to be able to run a sample script. So we're going to call it vi sample.yml. And here we have a sample playbook. We have the name, we have the host, we have the root user, and we have the task. And in the task, you actually see that we're looking to create a virtual web page with the content of welcome so that we can actually see that the web page is loading. And all of this is written with a very basic XML format called YML, which stands for yet another markup language. But it's very flexible and it's very easy to learn. So let's see if we can go ahead and actually run this playbook so you can actually see it in action. And so we're going to type in Ansible-playbook sample.yml. And this will run the sample YML script --syntax-check. Then we type in Ansible-playbook sample.yml. So I had some issues there, so I'm going to try that again. And let's go in and write the command again. So Ansible-playbook sample.yml-syntax-check, and then run the actual playbook itself. And let's see if it works. Yes, everything's working. And it'll take a moment for everything to initialize. And now what we want to be able to do is go back to our web browser and see whether or not we were able to create that default web page with the word welcome in it. Because that was the command that we created in our playbook. And there we are. There's the word welcome, exactly as we planned. And we can go back and we can review the playbook that we created just to validate that. So let's go back into the screen here and let's go in and look at the YAML page. And there we are. We see that the word welcome is there, exactly as we expected. Now let's step into our final area, which is network monitoring using a tool called Nagios. So before you had Nagios, sometimes you didn't know whether or not your network was working. In fact, the worst case scenario was when your customers called up and said, hey, your website's not working. The challenges you had is that you didn't know how the usage of the server was being managed. You didn't know whether you were up to 80% usage, utilization on that server, or if you were at 50%. It was difficult to get that information easily. With Nagios, you're able to set up email notifications and other notifications that allow you to stay ahead of issues that you would have within your environment. So with this example, if you're looking for memory utilization, you can receive a notification telling you that your memory is almost full on a particular server and that you should be setting up a new server. In this instance, use Ansible to set up another server. So again, as with the other tools that we've been covering, Nagios is an open source tool and it's specifically for monitoring systems, servers, and networks within your infrastructure. Very easy to use. It has comprehensive monitoring tools that you can set and control. It is highly available and it is designed specifically specifically a problem remediation. You want to set it up so that it is the eyes and ears of your network without you having to constantly monitor your network. So the way that Nagios works is that it's just constantly checking out your environment. So the Nagios server is constantly checking the status of your systems. It then is able to create visualization tools of that data, so you can actually then make quick responses. Or you can even send out alerts, such as an email alert or a push notification alert. In this video, we're going to take you through the steps that you need to follow if you want to set up Nagios and the dashboard Nagios provides to help monitor your network. So the first thing you want to do is go to nagios.com, and you can either download the application, or you can actually do what we're going to do here is actually just log into the actual application running on the Nagios website. So for that, you want to go to nagios.na.demos.nagios.com, and you can use the administration or normal user access IDs that Nagios provides. And we've gone ahead and we've actually pre-filled in our ID with Nagios admin and Nagios admin for the user ID and password. Of course, you wouldn't do that in normal real life. So that brings us into the Nagios dashboard. And what you're going to notice is that there are three distinct areas that you should want to focus on. You have the fixed sources, which is all your actual physical hardware that you're monitoring. You have alert summary and abnormal behavior. So let's go check out the fixed sources. And so we have two default fixed sources here, and one in Chicago, one in Tulsa. And you can go ahead and set up additional sources, but what you'll see is that this provides a quick dashboard of the activity in the last 30 minutes, the amount of usage on the disk. You can go ahead and under the behavior tab, and you can modify how you're monitoring and updating the actual source itself. And then the data from these reports will be from these sources will actually be then used in reports, queries, and alerts that you'll use. So we're going to go back to the board, and here you are. Here's the two fixed sources. So let's look at alert summary. We're going to expand that out. And the alert summary provides just an overview of the alerts that are being managed. The alerts that you see here are the default alerts that have been created as part of the test environment. It's very easy to create alerts, and in this instance you can see that the Chicago source is being used to manage the alert. What you can do is when you're actually setting up your own sources, you'll see that the alert will then point specifically to the source that it's pulling the data from. So in the PowerPoint, in the presentation that we just went through, you actually see how Nagios actually is the center of collecting all the information, but it's actually pulling the information from the different networks and environments that you have, and then it stores that data locally to be able to create the visualizations and the alerts. And we have here just a quick overview of an alert here inside of the summary, which actually shows green, which shows that the alert is actually good. Now there are three different types of colors. There's green, yellow, and red, but as you can see we have no critical alerts right now. And you'll see the same thing happening at abnormal behavior as well, where it actually goes ahead and shows you the different colors that are available. The thing that's great is that as soon as a warning status is created, then it allows you to trigger an email notification that gets sent out to you and has information in the email which you can then action. So the alerts are very important, and the alerts again are pulling the information from the fixed sources. So the abnormal behavior is just going to zero in and show any specific abnormal behavior that would be happening with your fixed sources. And so in this instance it's around bandwidth, and everything is green, so everything's looking good. So we're going to the source tab and we're going to look at the bandwidth graph, and this is a more detailed visualization of the bandwidth that's happening through the Chicago fixed source. Again, you can create your own fixed sources and you'll be able to see the actual usage such as the bandwidth graph for that fixed source on this screen. And at the bottom of the screen we have just kind of the most popular information that most network engineers are looking to assess on how a network is being used. So we can go ahead and we can select reports, and we can actually come in and we can either create our own custom report, or you can use one of the many saved reports that are already there. If you're new to Nagios, use the saved reports, because you'll be able to get in and get the great visualization tools that Nagios provide insights very quickly and be able to then action the information visually from what you're looking at. These reports are absolutely fantastic, and they're also really good to send to other team members that would have an interest in understanding the network usage and the different areas that you're managing. Now, if you want to get really specific on the type of data that you want in the report, you can actually go in and create a query, and the query can be customized to really however you want it to work. The points of view are very specific insights into different data points that interact, and they're very easy to create. A lot of them have been created, as you can see on the screen already, and as you can see on the left hand side, there's an edit button that allows you to edit and modify those points of view very quickly. Now we're going to go ahead and create one right now, and we're just going to put one in. We're going to put the limiter for an IP address. We're going to change the data lifetime. We can either do hours, days, or weeks. We do 24 hours, that's fine. So we'll just go ahead and we'll see what we have on the screen. And as you can see, there are just a lot already created. Select one, we'll edit the FTP, and we'll see what the data lifetime for that is, and it all looks good. So a query will show all of the saved queries you've created, but you can actually go in and modify a query very easy. You can go in and create a query and really essentially ask it to pull any kind of information that you would be looking at analyzing that has been captured by Nagios. And there's a dictionary you can use that Nagios has on their website that allows you to get better access and understanding the querying constructs you can put together. The alerts, in my opinion, are the most important part, because these are the actual actions that interact with the data sources and will trigger alerts that get sent to you. So if we go back to the presentation again, you can see that we're analyzing a lot of data, but it's the data that gets sent to you as an alert that allows you to immediately understand why you need to be able to go in and check out your network. And this is why you're really using Nagios, because you need to have those alerts. And so what we're going to do here is we're going through the steps you use to create an alert, and we're just going to do an alert here that is going to be on analyzing bytes of traffic. And the final step is to actually go ahead and save the alert and really put in what the alert notification model method is going to be. The default is to use an email, which is great, but you can use a Nagios alert or SMP, a simple network protocol alert, or just use a command. Email is definitely the easiest one to use, and so getting started, I would recommend you use email. So we're going to go ahead and we're going to create one. We're going to do one on workflow, and we're going to set up the way in which we're going to manage this. So the threshold is going to be 34 bytes with a critical threshold of 50 bytes, which is very small. I expect an alert to be triggered because of this. And we're just going to use the default emails to send out. And you'll see by default that the new alert is now impending. And the reason why we have it impending is that it's just there to be reviewed by the system to make sure it meets all the standards. I don't think that'd be a problem. And I'm just looking at some of the other different commands we have here. So if we go back, and we can get alerts from other Nagios networks. We connect to different networks right from this configuration screen. Same thing with the SMP receiver. We can use simple network management protocol to connect to other receivers. And the command tab allows us to create scripts that can be triggered from alerts that get created. So you may want to have something that triggers a rebuild of a network environment, which would allow you to authenticate through other systems. Now, of course, there are other things that you can set up in the Nagios dashboard. So, things like information on your profile, defaults here, such as language and your username. You have the same thing for a system administrator, where you can actually go in and set defaults for the sysadmin. There's LDAP AD integration for simple for SAML authentication. Go back to the main dashboard. If we scroll down, you'll actually see that we have an alert has been approved. That's the alert that we created before, and it's now saying critical because more than 50 bytes of information have been sent over our test network in the fixed source of Chicago. Surprise, surprise, 50 bytes is very easy to do. So it's good to see that the system is working correctly. And this is how our Nagios environment works. And from here, the next step is for you to be able to set up and configure Nagios to run with your infrastructure.
If you are here, you're probably wondering how to become a DevOps engineer. Well, you are in the right place. Today, we are diving into the ultimate DevOps engineer roadmap. DevOps is all about blending development and operations to streamline and speed up the entire software development process. DevOps engineers are in hot demand and the salaries are pretty amazing too. Depending on your experience and where you are, you could be making anywhere from $90,000 to over $150,000 a year.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
So stick around. In this video, we'll walk you through the ultimate roadmap to becoming a DevOps engineer. We'll cover everything you need to know step by step to help you succeed in this fantastic field. So these are the contents that you must learn to become a DevOps engineer. So better take a screenshot of this. Also, if you are looking forward to make a career in DevOps, definitely check out Simplilearn's professional certificate program in cloud computing and DevOps. This comprehensive course offers in-depth learning with thorough understanding of cloud computing principles and DevOps practices, guided by expert instructors with real-world experience. You'll engage in hands-on projects and real-world scenarios, building a robust portfolio that showcases your skills. Plus, the program is designed to help you gain industry-recognized certifications, making you a standout candidate in the job market. Don't miss this opportunity to advance your career and stay ahead in the ever-evolving tech landscape. Check out the course link in the description box and pinned comments. So let's get started. So first up, we have the Software Development Lifecycle, or SDLC. So the software development lifecycle is a process used by the software developers to design, develop, and test high-quality software. It consists of several stages. Each stage helps ensure the software is reliable, functional, and meets user needs. So, understanding SDLC is crucial because it gives you a holistic view of software development. It's like knowing the recipe before you start cooking. So, the different phases of SDLC are requirements gathering, understanding what the stakeholders need, design, planning the solutions architecture, implementation, which is writing the code. Then comes testing, which is ensuring the code works as intended. Then comes deployment, which is releasing the software to users. And finally, maintenance, which is updating and fixing the software as needed. So each phase has its own importance, and knowing these phases helps you understand how DevOps practices integrate to make the development and deployment processes more efficient and reliable. So next, let's talk about Linux. Linux is a type of operating system like Windows or Mac OS that runs on many servers, computers, and devices around the world. It's known for being stable, secure, and free to use. But why Linux? Because it's the backbone of most server environments you'll work with. Here are the essentials you should focus on, which are command line operations, shell scripting, learn Bash to automate repetitive tasks, system administration like understand how to manage users, permissions and processes, and package management. So Linux is used everywhere in the server world, and knowing it well will help you fix problems, automate tasks, and manage servers easily. Now the next one is learning a scripting or programming language. So knowing a scripting language like Python, Ruby, or even Bash is essential. These languages help you automate tasks, write scripts, and manage infrastructure. So here's why you should learn scripting. Automation. Write scripts to automate repetitive tasks such as backups, deployments, and monitoring. Configuration management. Tools like Ansible use Python for automation. Infrastructure management. Use scripts to manage cloud resources, databases, and more. So choose a language and start building small projects to get hands-on experience. I highly recommend Python due to its simplicity and extensive libraries. Now, Git is next on our list. Git is the most popular version control system out there. It allows you to track changes, collaborate with others, and maintain a history of your code. So key concepts to learn include repositories, how to create and manage them, commits, recording changes to the repository, branches, which is working on different features simultaneously, and merging, which is integrating changes from different branches. So familiarize yourself with platforms like GitHub, GitLab, and Bitbucket. These platforms facilitate collaboration and code management in a team environment. Now, networking and security are critical components of a DevOps engineer's skill set. You'll need to understand how data flows through networks, how to set up firewalls, and secure your applications. So, focus on these areas. Basic networking. Understanding IP addresses, DNS, HTTP, HTTPS, and TCP/IP protocols. Network security. Learn about firewalls, VPNs, and encryption techniques, and application security. Implement security best practices such as input validation, authentication, and authorization. So this knowledge will help you build secure and reliable systems, ensuring data integrity and confidentiality. Now let's move on to cloud providers. So AWS, Azure, and Google Cloud Platform are the big players here. So start with one and learn the basics. So number one, compute services like EC2 AWS, VMware in Azure, and Compute Engine in GCP. Then comes storage services like S3 in AWS, Blob Storage in Azure, and Cloud Storage in GCP. And then database services like RDS in AWS, SQL Database in Azure, and Cloud SQL in GCP. So understanding cloud services is crucial as most modern applications run on cloud infrastructure. So learn about IAM, which is Identity and Access Management for security, and explore cloud-specific services and tools offered by these providers. Now next, you need Infrastructure as Code, or IAC, which is a game changer. So Infrastructure as Code is a way to set up and manage computer resources like servers and networks using code instead of doing it by hand. So you write scripts that describe what you need, and then tools like Terraform or Ansible read these scripts and set everything up for you automatically. So this makes it easy to create, update, and keep everything consistent every time. This means you can version control your infrastructure just like your application code. So the key benefits include consistency, which ensure that environments are identical. Then scalability, it easily replicates environments across multiple regions, and then version control, which track changes to your infrastructure over time. So you can start by writing simple Terraform scripts to provision resources or use Ansible to automate configuration management. Now next up we have microservices and containers. So microservices architecture allows you to break down your application into smaller independent services. So containers with tools like Docker package these services and their dependencies, ensuring they run consistently across environments. So you should definitely focus on microservices, which is understand the principles of designing and building microservices. Then Docker, learn how to create Docker files, build images, and run containers. And then container registries. So use Docker Hub or private registries to store and share images. So these concepts will help you build scalable and efficient applications that are easy to deploy and manage. Now following containers, we have container orchestration. So Kubernetes is the go-to tool here. It manages the deployment, scaling, and operations of containerized applications. So the key components that you need to learn of Kubernetes are: number one, pods. The smallest deployable units that can contain one or more containers is called pod. Next, services. Networking components that define a set of pods and a policy by which to access them. And then deployments, which are controllers that manage the desired state of pods. So learning Kubernetes can be challenging, but it's incredibly powerful. It automates many operational tasks, allowing you to focus on building great applications. Now moving on to next, continuous integration and continuous deployment, or CI/CD, are at the heart of DevOps. So tools like Jenkins, Circle CI, and GitLab CI help automate the process of testing and deploying code. So here's why CI/CD is crucial. Continuous integration automatically tests your code to catch issues earlier. Continuous deployment, it automatically deploys your code to production, reducing time to market. And then pipelines, it defines the steps to build, test, and deploy your application. So mastering CI/CD will make your development process more efficient and reliable, allowing for faster and more frequent releases. So next, monitoring and logging. So monitoring and logging are essential for maintaining and troubleshooting your applications. So tools like Prometheus, Grafana, and ELK Stack, which is Elasticsearch, Logstash, and Kibana, provide insights into your system's performance and help you diagnose issues. So you must focus on metrics, which is track performance metrics like CPU, memory, and network usage. Logging, collect and analyze log data to troubleshoot issues. Alerting, set up alerts to notify you of potential issues before they become critical. So by setting up proper monitoring and logging, you ensure your systems run smoothly and can quickly respond to any problems. So now, DevOps is not just about tools and technologies. It's also about people. So collaboration and communication are crucial. You'll be working closely with developers, operations teams, and other stakeholders, which mean you must definitely focus on communication tools, like start using Slack, Microsoft Teams, or other tools for effective communication. Then comes project management. So utilize tools like Jira or Trello to manage tasks and projects. And then you must develop soft skills. So develop empathy, active listening, and clear communication to work effectively in a team. So being able to convey ideas clearly and work effectively in a team is a key and lead teams. So understanding the strategic aspects of DevOps, such as implementing best practices, driving cultural change, and aligning DevOps initiatives with business goals is crucial. So focus on best practices. Implement and advocate for DevOps best practices within your team. Next, cultural change. Foster a culture of collaboration, continuous improvement, and learning. And then strategic alignment. Ensure DevOps initiatives align with business objectives and deliver value. So leadership skills will help you inspire and guide your team towards success, making a significant impact on your organization.
Do you know, friends, that Kubernetes is also called K8 or Kube? It is an incredibly powerful platform that helps you manage and scale applications automatically. But it can feel complex and overwhelming at the same time. Many people find Kubernetes a bit tricky when they read through the documentation, especially when they are trying to understand how all the pieces fit together to manage containers. In this video, we are going to break it down for you in easy terms. We will explore two types of nodes in Kubernetes, the master node and the worker node. We will talk about how these nodes work together inside the cluster to manage and orchestrate your applications. So guys, without further ado, let's get started. But before that, just a quick info guys. Simplilearn has got DevOps Engineers Master Program. You can become a DevOps expert by joining this course. In this course, you are going to learn about Docker, Kubernetes, Ansible, Terraform, Prometheus, Jenkins, Microsoft Azure, and many more technologies. So guys, hurry up now and join the course. The course link is mentioned in the description box. So guys, let's start with understanding first what is pod. A pod is the smallest unit in Kubernetes. It is like a wrapper around your application. Inside a pod, there's usually one or more containers. Now you'll be wondering, what is a container? A container is where your actual application runs. It includes everything that the app needs to function, like code, system, libraries, and dependencies. Containers are lightweight and can be easily moved across different environments, making them very popular in modern software development. You can think container like a box that has your app and everything it needs to run. Whether you run it on your laptop or on a cloud server or inside a Kubernetes pod, the container will always behave the same way. Let me give you one example. Suppose you run an online e-commerce store. You have a front-end web app that the customers see and the back-end, the database that stores the product information and orders. In Kubernetes, you might choose to package the front-end and back-end as two separate containers. So you could run both the web app and the database inside the same pod. In this case, both containers, front-end and back-end, share the same resources, such as memory and network. This might be useful if they need to be closely coupled and always run together. Now, pods are basically responsible for managing resources for containers inside them, like the memory, CPU, and storage. And each pod runs on a node, and Kubernetes decides which node will run on each pod. Now let's understand the Kubernetes architecture. So guys, as we all know that Kubernetes is an open source platform designed to automate, deploy, scale, and manage centralized applications. It provides a powerful way to ensure that your applications are running efficiently and can easily scale across multiple machines, and can also recover if something goes wrong. At the heart of Kubernetes architecture, there are worker nodes and master nodes. These two components work together to ensure your apps are always running smoothly. In this video, we will take a closer look at each of these components and how they interact with each other. So let's understand first the worker nodes. Worker nodes are the machine which can be either physical computers or virtual machines where your applications actually run. Think of them as the workers for your Kubernetes cluster. They execute your app workloads, handle the tasks required them to run. Each worker node in Kubernetes runs these three main processes. That is container runtime, kubelet, and kubeproxy. Let's understand each one of them one by one. The first process is container runtime. The container runtime is like the engine of your worker node. It is responsible for running your applications, which are packaged into containers. Containers are basically lightweight standalone units that contain everything your app needs to run. This includes code, system libraries, and dependencies. The container runtime is a software that ensures these containers are properly managed and executed on each worker node. One of the most popular container runtime is Docker, as you can see all over here. So there are two instances of first, there is a my app, which can be a front end. Then you can consider this as the backend. So guys, you can consider something like this. These two as your two containers. This can be a front end, this can be a backend or database. Now there's a container runtime all over here, which can be Docker in this case. So the container runtime in this case is Docker, and it is ensuring that the container for your web app is running on the worker node. So if you have multiple applications, they will be packaged into separate containers, and container runtime will manage them, making sure they are running as expected. The next process that we are going to discuss about is called kubelet. Kubelet is like a manager that oversees everything happening on a worker node. It talks to the master nodes, which are responsible for managing the entire cluster. The kubelet gets instruction from the master node detailing which application or pods needs to be run on the node. It ensures that these applications are running by managing containers inside the pods. Unlike container runtime, which is specific to managing containers, the kubelet handles the interaction between Kubernetes and the worker node. It is responsible for making sure that the right number of containers are running, that the resources like CPU, memory, and storage are allocated properly to those containers. So you can say, for example, we have the master node that sends a request to the kubelet saying run 2 containers for the web app. So one container is there for web app and one is for the database. The kubelet will check the available resources on the worker node and ensures that the containers are up and running. It also continuously monitors the health of these containers to make sure they don't crash or run into problems. If container fails, the kubelet can restart it based on the policies defined in the Kubernetes, ensuring that the application remains highly available. I hope so you would have got an idea regarding kubelet. Now let's move ahead and understand about kubeproxy. Think of kubeproxy as a traffic director for your Kubernetes cluster. In a distributed systems like Kubernetes, your applications which are running on different nodes, kubeproxy is responsible for managing network traffic and ensuring that data is routed correctly between different services and pods. When your application needs to talk with each other, in this case, kubeproxy sets up the necessary network rules and ensures that the traffic flows smoothly between different pods, services, and nodes. It manages the internal networking of the cluster and ensures that each pod has a unique IP address. Now, let's move ahead and understand about the working of master nodes. While worker nodes handle the execution of the application, master nodes are the brain of the Kubernetes system. The master node manages the overall state of the cluster and makes decisions about which application should run and where they should run. The master node constantly monitors the clusters to ensure everything is working as expected. There are 4 key components that make up the master node. The first one is API server. The API server is like the front desk of the Kubernetes control plane. It acts as an entry point for all the requests you send to the Kubernetes. Whether you are creating a new application, checking the status of your pods, or scaling your app, you communicate with the Kubernetes through the API server. The API server handles all these requests and ensures that they are passed on to the correct components within Kubernetes. For example, let's say you want to deploy a new web application in your Kubernetes cluster. You would send a request to the API server, which will receive the request. It will validate it and pass it to the appropriate components, like it can be a scheduler or a control manager. Now, let's move ahead and understand about the second component, that is the scheduler. If I talk about the scheduler, guys, the scheduler is like a smart planner for the cluster. It is responsible for deciding which worker node should run a new application. When you create a new app in Kubernetes, the scheduler looks at all the available worker nodes and determines the best node for the app to run on. Based on available resources like CPU, memory, and network, the scheduler ensures that your apps are distributed efficiently across a cluster so that no single worker node is overloaded. Now let's move ahead and understand about control manager. The control manager is like the quality control department of Kubernetes. It constantly monitors the state of cluster and ensures that everything is running as it should. If something goes wrong, like a pod crashes or a node goes offline, the control manager steps in to fix it. The control manager is responsible for ensuring that the desired state of the cluster matches the actual state. If you define that you want 3 replicas of an app running and one of them crashes, the control manager will automatically create a new replica to maintain the desired state. Now the final component is etcd, which is also called as the cluster brain. etcd is a database that stores all the data about the Kubernetes cluster. It is often referred to as brain of the cluster because it keeps track of everything, including the apps which are running, where they are running, and the overall state of the cluster. etcd is a distributed key value store, meaning it can store data across multiple machines and ensure that it is highly available and fault tolerant. This is crucial for Kubernetes because the entire system relies on etcd to know how the current state of the cluster is. For example, if you want to deploy a new app, Kubernetes stores information about the app, like its configuration, location, and state in etcd. If something happens to the cluster, Kubernetes can recover the current state from etcd. Now let us look at the example of setting up a cluster. Now that we understand how worker nodes and master nodes work, let us go through a simple example of a Kubernetes cluster setup. In this, you have a basic cluster with 2 master nodes and 4 worker nodes running on it. Let us say these pods contain a web app and a database. You start by creating pods, and each pod contains 1 or more microservices for your web app. Then the scheduler steps in. Once you submit the request to Kubernetes through the API server, the scheduler looks at the available worker nodes and assigns both the pods to your worker nodes. Then comes the kubelet, which manages the pod. The kubelet on the worker nodes receives the instruction from the master node to run on the 2 pods. It starts a container inside each pod using Docker or another container runtime, and it ensures they are running smoothly. Then we have kubeproxy, which handles the communication. The web app pod needs to communicate with the database pod. kubeproxy sets up the network routes and ensures that the 2 applications can exchange data securely and efficiently. Then we have control manager, which ensures the stability. If one of the pod crashes or fails to start, the controller manager detects the issue and creates new instance of the pod, ensuring that both your web app and the database stay online. Then finally, we have the etcd, which keeps up the track. All the information about the state of the cluster, including running pods, their location, their status, is stored in etcd. This ensures that the cluster can recover from any issues and always knows what is happening. So this was a simple example illustrating the cluster setup. Kubernetes is a powerful platform for managing containerized application across cluster of machines. By understanding the roles of worker nodes and master nodes, you can see how Kubernetes automates the deployment, scaling, and management of your apps.
Hello, and in this video, we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the 2 different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing 2 primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list.
In today's era of microservices and distributed systems, containerization has revolutionized how applications are built and deployed. One such tool is Docker. Docker is a leading containerization platform which not only helps in packaging applications, but also provides a robust networking features that allows containers to communicate with each other. In today's job scenario, every company is asking you to learn Docker. So for the same, we have covered Docker networking tutorial in today's video. Before we move on, just a quick info guys. If you want to become a DevOps expert, then you can join Simplilearn's course, which is in collaboration with IBM. In this DevOps Engineer Certification course, which is developed in collaboration with IBM, will help you refine your skills. In this course, you're going to learn about Docker, Kubernetes, Ansible, Terraform, Prometheus, Jenkins, Microsoft, and Azure DevOps methodologies. So guys, hurry up now and join the course. The course link is mentioned in the description box. So let's get started. So guys, I have opened official documentation of Docker and we are going to learn about networking. So you would be wondering why Docker networking? So guys, basically Docker networking allows containers to communicate securely and efficiently both with each other and also with the outside world. Networking is a very critical part of containerized applications because in most of the real world cases, applications are not isolated. They need to talk to databases, APIs, microservices, and also external clients. In traditional environments, if I talk about, networking setup and management can be cumbersome or a little bit complex, in which you would be required a complex configuration of firewalls, subnets, NATs, which is Network Address Translation Protocol. But Docker abstracts much of this complexity, providing out-of-the-box networking solutions, which I will show you in today's hands-on tutorial. Now, let us consider one example. So, to suppose, in this typical scenario, you can see the front end is communicating with a backend API. And the backend, you can presume that it is also communicating with some database. Okay, so this is our database. When these services are containerized, so suppose you can see all over here, the front end part is containerized all over here and back end part is put into the container all over here. Now they are communicating internally. So with the help of Docker networking, you can connect these containers in an isolated environment where front end container sends requests to the back end container, which then queries the database. Okay. So with the help of Docker networking, this communication is possible. And we are removing any complex manual network configuration that is needed. So let us see. So suppose we have the front end container, we have the back end container, here is our Docker, and suppose we are using EC2 instance as a host. Now, let us try to understand first, what is the difference between Docker and VM networking? Now guys, if I talk about Docker versus virtual machine. So in a virtual machine based environment, each virtual machine typically runs an entire operating system and it has its own dedicated virtual network interface. Okay, these interfaces must be connected to a physical or a virtual switch, and which the underlying technology is a hypervisor. So configuring virtual networking involves setting up IP addresses, subnets, routing rules, and firewalls. For example, if you want to connect two virtual machines, one running a backend service and another running a database. To communicate with each other, you need to assign static IP addresses, configure network routes, and ensure that the firewall rules allow traffic between them. Such of a manual task we have to do. And additionally, if external clients also need to connect to the backend, more routing and firewall configurations are required, which makes this process so complex. But if we talk about Docker networking, then Docker saves us. Docker networking is more lightweight, flexible, and efficient. When you run a container, Docker provides a virtual network interface, or you can say a virtual Ethernet. Okay. Now, this VEth or virtual Ethernet and containers can be connected to Docker's virtual network bridges or custom networks, which we are going to learn a little bit later. In Docker, you don't have to worry about manually configuring subnets, routing, or NAT. Docker automatically handles most of the networking setup for you. With Docker's built-in network, such as default bridge network or user-defined network, containers can communicate with each other very seamlessly. Now, you'll be wondering, how do containers communicate with each other in terms of networking? So let us see this example. So you can see all over here. Suppose we have an application container all over here, and the IP address for this is something like 172.18.0.12. Now, when you initialize the container, the Docker also gives it the IP address, which is the virtual Ethernet network or virtual network, and which we generally called it as Docker 0. Okay. Now, similarly, the host, where you can say it is an EC2 instance, okay, with 192.16.0.12. Okay. Now, just forget it for a moment, okay. We'll not consider this. So, when app is directly trying to communicate with the host, okay, so nothing is involved. Let me remove this. Now, so in this application, you can see all over here, the IP address for this is 172.18.0.12 and the host with echo, so Docker has given this a network of 192.16.0.2. Now, when this is trying to communicate with each other, I ask you one question. You can pause this video. Will they be able to communicate with each other? So guys, the answer for the same is no, not at all. There's going to be a network error because they are belonging to different subnets. Now, if I talk about how this problem resolves by Docker, so Docker does what, guys? Docker provides a virtual Ethernet, which is called Docker 0, all over here, and which makes a network configuration. The default one is bridge network, okay? Now, both of them can easily communicate with each other. So say one good example, I want to take it with this. So say you have a login container, you have the payment container, okay? Now, say both of them have a default network configuration in which, say, bridge network configuration. Don't worry about it, we will learn the different type of network configuration. So we are presuming that this network configuration is a bridge network. Okay. Now say login container is a kind of a user-based container where you have to log in through your email, ID, and password. And similarly, you have a more crucial or you can say more important part of this application is a payment container, which is very, very important. Okay. Now, what you do in order to communicate, so I told you earlier, so Docker does what? Docker creates a virtual Ethernet connection, okay? And this is Docker 0, okay? Now, say we are using the same path, okay? The same payment C with this container, payment container, is trying to communicate with the host through this, okay? Through this Docker O network. Now, both of them are trying to communicate with each other. Now, in the payment container, say in this application where user types its credit card number and a lot of other payment details. So hackers can easily exploit it because they are not at all secure, first of all, and they are trying to communicate through the same path. So a hacker can come up and steal some important secrets and data that can be vulnerable for your application. Now, in order to secure this application, guys, we have another scenario. What we do, basically, we need to isolate this from this container. Now, the solution for this is creating your own custom bridge network, okay? So that the IP address for this and IP address for this do not belong to the same category, okay? So this needs to be isolated from each other. So let me show you one more example. So this is a proposed solution in order to do the same. So what we do, basically, so in order for connecting at this network, what do we do? Basically, we are creating our own custom network. That's one of the important features of Docker, which we'll be doing in our today's tutorial also. So now the path is not same. So hackers cannot come and steal your important credentials or data. Now, This is one of the very basic, you can say configuration all over here. Now this is our next configuration. So this architecture we'll be doing in our today's tutorial. So imagine we have these two containers, login and product, okay? And they are pretty much communicating with each other over the same network, which is Docker row, okay? So Docker has provided the virtual network for it, and we generally call it by Docker 0. And it is communicating with the host, okay, with the etho of 1.172.16.1.2. Now, the payment process is very, I would say, very critical part of the application, where you need to prevent its, you need to keep it isolated. You don't want any of the containers to communicate with this. Now, what you do basically all over here, that you create your custom virtual bridge network, which communicates with the host directly. So this payment container is completely isolated from this container. So in this way, you are making this container isolated, and also you are making your application secure. And this is what is the beauty of Docker. Now, what we are going to do all over here, the next part, which I want to tell you about the type of network. Since I have discussed you regarding the bridge networking, so let me tell you what exactly a bridge networking is. So say there are three types of networking, okay? The first one that we have all over here is bridge networking. So Docker creates a virtual network interface on the host with a typical name of Docker 0, as I told you earlier. This virtual bridge connects all the container on the default or user-defined bridge network, which allows them to communicate with each other with the host. And typically all the containers receive the internal IP addresses from a certain private subnet range, basically, which can be 172.xxx, okay? So bridge networking is a special type of networking. It's a very default networking, which even if you don't define it, Docker is going to define it for you. And here, your network interface or virtual network interface, you're going to get Docker 0 all over here. That's a basic thing. And bridge connects all the container, okay? So important part all over here is with the help of bridge, so it connects all the container. Now, how bridge networks work? So let us take this example, what we have all over here. So you can see this is an app container, okay? Say the IP address for this is 172.18.0.12, which is assigned by the Docker, okay? Now, this cannot communicate with each other, as I've already told you. So this application container, in order to say our host is an EC2 instance. Now, in order to communicate this app with this host, you need a bridge network. So that's why here Docker 0 is our bridge network, which is trying to communicate, because they are belonging to different subnets, okay? They cannot communicate. So for the same purpose, Docker gives us the bridge network. So now, with the help of NAT or Network Address Translation Protocol, these containers can communicate with each other. So this is how our bridge network is working. But the thing with the bridge network is all the containers can communicate with each other. So in this scenario, if I tell you what kind of network they all have, so they are all sharing the bridge network configuration, so that this login container and the product container in a given microservice are easily able to communicate with each other. So Docker 0 is our bridge network, and here you are interacting with the host. Now, if I talk about some of the security concerns with respect to the bridge network, so login and product, they all have shared network, okay? So all the containers connected to the same bridge network can communicate with each other. But if one of the container is compromised, it could potentially target the other containers also on the same network. So unless additional network policies or firewall rules you have given, this can be a little bit problematic. The second scenario that I can see is access to the host port. So if port forwarding is used to expose the container services, then attackers can potentially target the host machine through the misconfigured or open ports. So these are some of the security concerns with respect to this. Now let us discuss about the host networking. In the host networking, the container bypasses Docker's virtual network interface and shares host machine's network stack. It means that the container does not get its own internal IP address. Instead, it uses the host IP address and the network interfaces directly. This setup is basically useful for applications that require high network performance, low latency, and also a direct access to the network resources. But this is also very, you can say, security concerning. So here, all of them will be communicating through the same network. And the problem which I told you earlier, the attackers can easily come in and steal your important data. So instead of assigning the internal IP address from a private subnet, container directly reaches via host IP address. For example, in this scenario, say our host has an IP address of 192.16.0, okay, and a container is running with the host networking will be somewhat around 198.61.1.100. So here your IP address is going to change. So if I talk about the IP address for this, it will be using the host IP address. And they all will be communicating with the same network, okay, and which can be a little bit problematic. The security concerns will be more. And the container can use the same network interfaces, ports, and network routing as the host is using. Okay, so you are not assigning any private IP address to this container if you are using the host networking. So in this configuration, we can see there is no network isolation is there. Okay, port conflicts can also happen, like container running with the host networking share the same network namespace as the host. And this means basically that if a container tries to use the port that is already in use by a service, say it is using a port 80 or for a web server, then there will be conflict. So you need to follow careful planning, okay, to avoid these kind of conflicts. Then no NAT is happening all over here. So host networking is not using network address translation protocol. Containers are exposed directly to the host network interfaces, and it reduces the security in this scenario. So for these reasons, host networking is typically not recommended to use in production environments unless or absolutely necessary for performance-based reasons. So I hope so you would have got some idea regarding host networking configuration. Now let us move ahead and try to do the hands-on based on this architecture. So I'll be using a local repo, and in that I will be creating the container for login, product, and I will be assigning them the bridge network. And then I'll be creating my own custom bridge network, okay, so that this security concern does not happen, because if it is using the same, as I've told you earlier, same network of Docker 0, then the attackers can exploit this and steal away your important credentials, which we don't want to happen in our application. So we are creating a custom bridge network, and this will be all happening in our terminal. So let us start our Docker engine and directly deep dive into it. So in our hands-on video, what we'll be going, so we'll be using the same architecture that we have discussed, which is this one. So we are going to create a login container, a product container, and connect them with the bridge network. Then we are going to create a payment container and with a virtual bridge network. And we'll be using the ping command to check from where the communication is happening, which is reachable and which is not. So it's a pretty basic tutorial. Please follow me along. And if you have any doubt, you can pause the video and go back. So container 1 is our login container. This is our product container, and this is our payment. So I'll be using these variables all over here. So let us create our first container, that is container 1. And what you can do all over here, guys, that before creating the container, make sure that your Docker engine is up and running. So all over here, so since I have already created container 1 and container 2, so let me show you. It's going to show me error, but this is a command. So here, docker run /t, then -- name, then here is my name of the container, and I'm using Nginx latest, okay, Alpine version. This is a system's image. It is going to create this container 1. Now, if I try to enter it, since I've already have this container, now you can see I have got this container ID all over here. Similarly, you are going to get a container ID, but you will not get this error. Okay. So what I can do, I can remove this, okay, with a docker rm command, but I want to use the same variables. So for the same purpose, it's fine. Now, similarly, now let us create our Docker container 2. So we are going to get the ID for this also. So this we have already created. Pretty much fine. Now we have easily created this. Next thing is you need to install ping on your given containers. So what you can do, so if you haven't installed ping on your system, you can go all over here, apt get update y and apt get install y iputils/ping, which is going to install your ping command. So I have already installed ping on my system. Now let's proceed with our next thing. In our next process, what we are going to do, we are going to go inside our login container. So all over here, we can type docker exec 10 it, and the name of the container is container1. Okay, same name which we have given, which is a login container. So container1, then /bin/bash. Okay, now we are inside our container1, and here if I type ping v, so you can see all over here that ping is not installed on this container. So directly go all over here, copy this command and first update it. So you can see all over here that it has started updating the packages. Now our next command would be try to install ping all over here. Now let us install the ping command, and you can see ping we have successfully installed all over here. Okay. So we have successfully installed ping on our container. Now let us look at what number of containers we have installed. So you can see all over here, we have container 2 and container 1 already created all over here. Now let us move ahead and try to do more configurations. Now let us try to inspect the network for the same. So I'll be using docker inspect command. So let's copy this. So you can see all over here, we have the IP address of 172.17.0.5. Just copy this, okay? And we are going to ping this from this terminal, okay? So from the container 1, we'll try to ping it up. So ping, then let's try again, ping. So I'm trying to ping 172.17.0.5. Just click enter, and you can see all over here, okay. So you can see all over here, when I'm trying to ping from this container 1 to product, so by default they have the bridge network configuration. And you can see we are getting the data from the container 2. So easily the communication is happening. This is a TCL handshake with ICMP protocol. And you can see the packets are being transferred. Now, what we are going to do next, we are going to create the next container. So let us go to the next terminal. And here, let us create our next. So, but here, we want to give a custom network configuration. So for the same, what I will do all over here, the same command, docker run d name. So I will just override this, the name of container 3. Okay. And here, what I'm trying to do is give a network called secure network configuration, which is a type called of bridge network only. And let us create this. Okay. Now you can see we have got the ID of this. So if I try to inspect this, okay, say docker inspect container 3. So we'll given an IP address all over here, and this is 172.18.0.3. Now if I try to communicate from this terminal, or stop this. Okay, if I try to communicate with the container 3, we will see the request will be timeout. So you can see we are not getting any response all over here, because here we have created a different or a custom bridge network which has isolated the container for our payment system. Now we'll see all over here that the request has been timeout. So you can see all over here that we are not getting any information of communication from container 1 to container 3. It's completely isolated. Similarly, what I'll do, let us go to the container 2. So instead of 1, I'll type 2 all over here, and we are into container 2. Now if I try to communicate all over here, since ping is not installed, so let us install the ping first. Okay, now after that, what you can do all over here, so you can just copy the same command, and you can see ping is installed. Now let us try to, let's clear the screen first. Now when I'm trying to do the ping, so I have again copied this IP address. I'll be moving to my next terminal, and so container 2 is trying to communicate with the container 3. So as I have told you earlier, that container 2 and container 1 are in the same connected network, which is a bridge network, so that the communication is happening very easily. But container 3 and container 1 and 2 are isolated. So you can see from here also I'm not able to receive any information or any details all over here of the communication between them. So similarly, for the same terminal 1, you can see still we are not getting any packets of data all over here. So in this way, we have completely secured one container from the another with the help of custom network that we have created, a bridge custom network, okay, with a parameter called, okay, network, in which I have given the name as secure network. So I'll show you the command again. So you can see all over here that we have created a custom container 3. Okay, so the command for giving the network, custom network, was like -- network, then here equal to sign, then here I'm giving my custom network. It is a very easy tutorial, but it's very important for your understanding the concept of Docker networks. So with this simple example, I hope so you would have got a brief idea regarding what is Docker networks, why do we need it, what are custom networks, what are the security things that we need to take care of when we are creating Docker networks with the help of bridge network, and how we can create the custom bridge network. And also we studied regarding the host network, what it is.
Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds, if not thousands, of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization, while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy reinforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. They should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. So at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and we'll take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macy, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macy will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macy really facilitates discovering and protecting that so you can concentrate on other things. AWS config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 buckets should be encrypted by default, all of them. Or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS config. So you'll see the AWS config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically GuardDuty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full-time, from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that will eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old, boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we are going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be sure that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high-level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. Then we have the actual request. Now we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions, because every API has fine-grained actions that we can control through IAM. And of course, many, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user, Tom, always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user from which that point on, you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the secure token service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather. that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you've just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could add further down, maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda, and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2, and click next permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service, because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3, and off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code, that will allow you to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been, your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps, like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features. And so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right. And now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create 2 users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create 2 new users. We'll start with one at a time. So one called user1. Now by default we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now, and also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object Lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users. Make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user one. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right, so now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists, all right? So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user1 and user2-MFA, then, let me just apply this, that would mean that user1 would not be able to see the contents of our object inside folder1, and user2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user1 and user2-MFA and prove this is actually the case. So I am now logging back in as user1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected, and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out, and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM, and we're going to be creating our first group. We're going to simply create the button or click on the button create group, and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one, or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying. You can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. You know, the same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users. The end user could be in the internet. The end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. with containers, that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. The one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes. Right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service. And it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then elastic network interface card is a virtual interface network that can be connected to an instance in VPC. So in other words, elastic network interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And these cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it a backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure a cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create a cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then a service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me. And it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it. And because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 that receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created it gets a new IP, right? So hardcoding IP is not, hardcoding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53. And finally, we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot. Meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be, utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53. It's highly scalable, meaning suddenly, let's say, the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up when you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application. get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can access it we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people in publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability. Otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these companies are very critical, they being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used with all the weighted routing. Their resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called simplylearn-demo-route53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me. Right, click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider, and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. If you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are two types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment, in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with the load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the autoscaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC, you don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, autoscaling, and then monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the clients would be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the client. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now, coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now, in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now, obviously, we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client-facing environment. Now, if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments and they are created in the Autoscaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the autoscaling group. So that's something which we have discussed already. Now, this autoscaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now, what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS. which is a simple queue service, and the queue service sends it to the worker environment, and then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what you have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability, whether that domain name is available with us or not. and it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description, it's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy our applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. And if you're a professional with minimum 1 year of experience and an aspiring DevOps engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no. Simplilearn's postgraduate program in DevOps from Caltech University in collaboration with the IBM should be your right choice. For more details, use the link mentioned in the description box below. So let's start with why are DevOps skills crucial? Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Docker file efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Docker file creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps Project. We deploy applications seamlessly across Azure services like App Service, virtual machines, and Azure Kubernetes Service, or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Addition insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, containerized web app deployment on GKE, scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes Engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing autoscaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, mastering version control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, effortless deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, mastering Terraform project structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisionals, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently.
DevOps has become an essential skill set for today's technology professionals, with many organizations seeking out talented individuals who can help them build and maintain their infrastructure. If you are looking to become a DevOps engineer, this video is for you. In this video, we'll be covering some of the most common interview questions for a DevOps engineer, as well as some tips on how to answer them successfully. We will cover infrastructure as code and CI/CD pipelines, along with many other important topics. You'll often be asked about your experience with ISA tools like Terraform and Ansible, as well as your knowledge of cloud providers like AWS Google Cloud or Microsoft Azure. We will also discuss tools like Jenkins, Travis CI, or Circle CI, as well as concepts of containerization and Kubernetes. There's a lot to learn and a lot to discuss in our DevOps Engineer Interview Questions video. So without further ado, let's get started. Also, if you are keen to learn more about DevOps and its concepts and want to attain a job in a renowned company, then Simplilearn's Caltech postgraduate program in DevOps could be the right choice for you. This comprehensive program will equip you with the knowledge and skills needed to master the DevOps principles, tools, and practices. So dive deep into containerization, orchestration, and automation framework like Docker, Kubernetes, and Jenkins. Get hands-on experience with cloud platforms and learn how to leverage the power of infrastructure as code. So don't miss out on this chance to transform your career and become a valuable asset to any organization. Click the link in the description to discover more about this DevOps course. Now, let's jump into the video. But before moving ahead, let's first understand what is DevOps. Now, DevOps is a set of activities and approaches aimed at enhancing the effectiveness and excellence of software development, delivery, and deployment. It brings together the realms of software development, depth, and information technology operations ops. The main goal of DevOps is to encourage seamless collaboration between development and operations team through the entire software development lifecycle. It achieves this through the utilization of automation, continuous integration, delivery, and deployment. thereby accelerating the process and minimizing errors in software development. Now, let's explore who is a DevOps engineer. Now, a DevOps engineer is an expert in developing, deploying, and maintaining software systems using DevOps practices. They work closely with IT operations, developers, and stakeholders to ensure efficient software delivery. The responsibilities include implementing automation, continuous integration, and continuous delivery or deployment practices, as well as resolving issues throughout the development process. DevOps engineers are proficient in various tools and technologies, such as source code management systems, build and deployment tools, virtualization, and container technologies. But how exactly to become a DevOps engineer? Now, depending on the business and the individual function, different criteria for becoming a DevOps engineer may exist. However, some specific fundamental skills and certifications are frequently needed or recommended. First is an excellent technical background. Now, DevOps engineers should be well versed in IT operations, system administration, and software development. Second is experience with DevOps tools and methodologies. Now, DevOps engineers should have experience with various DevOps technologies and processes, including version control systems, build and deployment automation, containerization, cloud computing, and monitoring, and logging tools. Third is scripting and automation skills. Now, DevOps engineers should have strong scripting skills and be proficient in using tools such as Buzz, Python, or PowerShell to automate tasks and processes for this cloud computing experience. Now, DevOps engineers should have experience working with cloud platforms such as Amazon Web Services, Microsoft Azure, or Google Cloud Platform, and in the end, certification. Some organizations may require DevOps engineers to hold relevant certifications such as Certified DevOps Engineer, CDE, or Certified Kubernetes Administrator, CKA, or AWS Certified DevOps Engineer Professional. Well, now, let us begin with some really important DevOps interview questions and answers, as we have already covered the roadmap of how to become a DevOps engineer. So the first question that we are coming up with is, how is DevOps different from Agile methodology? Well, DevOps is a culture that allows the development and operation team to work together. This results in continuous development, testing, integration, deployment, and monitoring of software throughout the life cycle. Whereas Agile is a software development methodology that focuses on iterative, incremental, small, and rapid release of software, along with customer feedback. Basically, IT addresses gaps and conflicts between the customer and developers. DevOps addresses gaps and conflicts between the developers and IT operations. Now, the second question is, which are some of the most popular DevOps tools? Well, some of the most popular DevOps tools include Selenium, Puppet, Chef, Git, Jenkins, Ansible, and Docker, which are considered really important in today's world if you want to become a successful DevOps engineer. The third question is, what is the difference between continuous delivery and continuous deployment? Now, we will address this one by one. So, continuous delivery ensures that you can safely deploy onto production. But continuous deployment ensures that every change that passes through automation testing is deployed to production automatically instead of manually. Continuous delivery ensures business applications are delivered as they were expected. Now, continuous deployment makes sure that software development and other processes like release are smooth and faster. Continuously, we also make changes to a production life environment through rigorous automated testing. But when it comes to continuous deployment, there is no explicit approval for a developer to require a developed culture. Question 4 is, what is the role of configuration management in DevOps? Now, configuration management enables management of and changes to multiple systems. Also, it standardizes resource configuration, which in turn manages its infrastructure. Also, it helps with the administration and management of multiple servers and maintains the integrity of the entire infrastructure. Next is, what is the role of AWS in DevOps? Well, AWS has the following role in DevOps. First is flexible services. This provides ready-to-use flexible services without the need to install or set up the software. Second is build for scale. You can manage a single instance or scale to thousands using AWS services. Third is automation. AWS lets you automate tasks and processes, giving you more time to innovate. Then comes secure. Using AWS Identity and Access Management, you can set user permissions and policies in your organization. And then comes large partner ecosystem. AWS supports a large ecosystem of partners that integrate with an extended AWS services. Now, if we talk about the sixth question, that is, name 3 important DevOps KPIs. Now, the 3 very important KPIs are as follows. Mean time to failure recovery. This is the average time taken to recover from a failure. Deployment frequency, the frequency in which the deployment occurs. Percentage of failed deployments, the number of times the deployment fails. Now, the 7th question is, what are the benefits of using version control? Here are some of the benefits of using version control. Well, all team members are free to work on any file at any time. With the version control system later on, VCS will allow the team to integrate all of the modifications into a single version. The VCS asks to provide a summary of what was changed. Every time we save a new version of the project, we also get to examine exactly what was modified in the content of the file. As a result, we will be able to see who made what changes to the projects. Now, inside the VCS, all the previous variants and versions are properly stored. We will be able to request any version at any moment, and we will be able to retrieve a snapshot of the entire project at our fingertips. A VCS that is distributed, such as Git, lets all the team members retrieve a complete history of the project. This allows developers or other stakeholders to use the local Git repositories of any of the teammates, even if the main server goes down at any point in time. So the next question is, what is the blue-green deployment pattern? Now, this is a method of continuous deployment that is commonly used to reduce downtime. This is where traffic is transformed from one instance to another. In order to include a fresh version of the code, we must replace the code with the new code version. The new version exists in a green environment, and the old version exists in a blue environment. Now, after making changes to the previous version, we need a new instance from the old one to execute a newer version of the instance. So this was the right answer. Next is, what is continuous testing? Continuous testing constitutes running of automated tests as part of the software delivery pipeline to provide instant feedback on the business risk present in the most recent release in order to prevent problems in step switching in software delivery lifecycle and to allow development teams to receive immediate feedback. Every build is continually tested in this manner. Now, this results in a significant increase in speed in a developer's productivity, as it eliminates the requirement of rerunning all the tests after each update and project rebuilding. Now, let's move to the next question. That is, what is automation testing? Now, test automation or manual test automation is the process of automating a manual procedure in order to test an application or system. Automation testing entails the use of independent testing tools that allow you to develop test scripts that can be run repeatedly without the need for human interaction. The next question is how to automate testing in DevOps lifecycle. Now, developers are obliged to commit all the source code changes to a shared DevOps repository. Every time a change is made in the code, Jenkins, like continuous integration tools, will grab it from this common repository and deploy it for continuous testing, which is done by tools like Selenium. So why is continuous testing important for DevOps? Any modification to the code may be tested immediately with continuous testing. This prevents concerns like quality issues and release delays that might occur whenever big bang testing is delayed until the end of the cycle. In this way, continuous testing allows for high quality and more frequent releases. So the next question is, how do you push a file from your local system to the GitHub repository using Git? Now, first connect the local repository to your remote repository. Now, git remote, add origin, and then you can see the code. And the second step that you need to do is push your file to the remote repository. Next question is, what is the process for reverting a commit that has already been pushed and made public? Now, there are 2 ways that you can revert a commit. Remove or fix the bad file in a new commit and push it to the remote repository. then commit it to the remote repository using this command. And second is create a new commit that undoes all the changes that were made in the bad commit. You can use this command for it. Next is explain the difference between git fetch and git pull. Now, git fetch only downloads new data from a report repository, whereas git pull updates current head branch with the latest changes from the remote server. The second difference is git fetch does not integrate any new data into working files, whereas git pull downloads new data and integrates it with the current working files. Git fetch users can run a git fetch at any time to update the remote tracking branches, whereas git pull tries to merge remote changes with your local ones. Now, coming to the next question. Explain the concept of branching in Git. Suppose you are working on an application and you want to add a new feature to the app. You can create a new branch and build a new feature on that branch. By default, you always work on the master branch, and the circles on the branch represent various comments made on the branch. So after you're done with all the changes, you can merge it with the master branch. Next question is, explain the master-slave architecture of Jenkins. Now, Jenkins master pulls the code from the remote GitHub repository every time there is a code commit. It distributes the workload to all the Jenkins layers, and when requested from the Jenkins master, the slaves carry out build, test, and produce test reports. The next question is, which file is used to define dependency in Maven? build.xml, pom.xml, dependency.xml, or version.xml. The correct answer is perm.xml. Next question that we are going to cover is explain the two types of pipelines in Jenkins, along with their syntax. Now, Jenkins provides two ways of developing a pipeline code, scripted and declarative. Now, scripted pipeline is based on GroovyScript as their domain-specific language. One or more node blocks do the core work throughout the entire pipeline. Now, the syntax is execute the pipeline or any of its stages on any available agent, define the build stage, perform steps related to building stage, define the test stage, perform steps related to this test stage, define the deploy stage, and perform steps related to the deploy stage. Now, declarative pipeline provides a simple and friendly syntax to define a pipeline. Here, the pipeline block defines the work done throughout the pipeline. So the syntax that follows is first, execute the pipeline or any of its stage on any available agent, define the build stage, perform steps related to building stage, then define the test stage, perform steps related to the test stage, define the deploy stage, and perform steps related to the deploy stage. Again, this was the code for declarative pipeline. And the last question for this video is, explain how you can set up a Jenkins job. To create a Jenkins job, we go to the top page of Jenkins, choose the New Job option, and then select Build a Freestyle Software Project. Now, the elements of this freestyle job are optional triggers for controlling when Jenkins builds, optional steps for gathering data from the build, like collecting Javadoc testing results and or archiving artifacts, a build script that actually does the work, or the optional source code management system like Subversion or CBS. Well, there you go. These are some of the most common DevOps interview questions that you might come across while attending an interview. As a DevOps engineer, in-depth knowledge of processes, tools, and relevant technologies is essential, and these DevOps interview questions and answers will help you get some knowledge about some of these aspects. In addition, you must also have a holistic understanding of the products, services, and systems in place. Here's an inspiring success story from one of our satisfied learners who has propelled their career with DevOps. This can help you boost your confidence and make a firm decision in this field. Do watch the video.
Now with that, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. And don't forget to like, share, and subscribe for more such helpful content. See you in the next video. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.